Good evening. My name is Eric Rogers. In the ME302 Thermodynamics summer course. Tonight we're going to be summarizing Chapter 4 from the textbook with help from High Fives notes from class and from the textbook. And I'll just be using both those as a reference. Now this chapter is basically the analysis of energy of closed systems. So basically, no mass is being lost. So there is no mass transfer. Okay. And what that brings up is a term called boundary work. So if you have a system where a piston is, we're talking about the work that the piston does, which is work boundary equals volume 1 to volume 2 of pressure times the derivative, or the integral of volume, which can be written as m v1 to v2 of pdv. Now, that's also, well, v1, v2 aren't volumes, they're areas on the graph, but it's also the area under the curve on a graph as I'm coloring in. With boundary work, one of the common things is constant pressure, and to find your work, it's your pressure V2 minus V1, and that will give you your constant pressure work. And for a system that has a spring in it, we the piston device with a spring, it's the two pressures summed and divided, and then it's so summed and divided times V2 minus V1, and that gives you your work boundary for a linear increase in pressure. So for ideal gases, ones that have constant temperature, these are the formulas for work boundary. Work boundary is P1 V1, natural log of V2 over V1. Or written another way, work boundary is pressure 2 V2 minus pressure 1 V1 over 1 minus N. Now these are basic formulas for this chapter. Well, for that part of chapter 4. The next thing that is brought up is energy bound for a closed stationary system. And we got the terms Q in, Q out, work in, work out, minus change in U, which is our internal energy. Q is your heat, and work is what we just talked about. So all these, Q in minus Q out plus work in minus work out, equals change in internal energy. And this is for a stationary system that is also closed, so no energy transfer, or no mass transfer. Okay, for the next part is enthalpy for constant pressure, and that's in regards to our internal energy, which equals change in H equals change in U plus work boundary. Or it's Q minus work boundary equals change in U. Or Q equals delta H. This formula is used to find your enthalpy or your change in energy of the system. Next, there's a topic called specific heats. everything has what's referred to as specific heat, which is how much energy a given material takes to rise 1 degree Celsius. So this term is specific heat for constant pressure, so like our boundary work problems we just talked to. And this one is CV for constant volume, in which there's no work for constant volume. And the relationships of these is du equals CV times your temperature dt. And dH is CPT dt. R is CP minus CV. And then the constant K is CP over CV. For incompressible substances, we have change in U equals C average T2 minus T1 for solids and liquids. Then we have change in H is change in U, C average T2 minus T1 for solids. And then for liquids, it's basically same thing, and P cannot be 0. And again, in this one, T cannot, T and change in T cannot equal 0, change in P cannot equal 0. So that kind of sums it up about specific heat. This chapter, this chart kind of explains the different things. So for isothermal or constant temperature, Q is MRT mass times the gas constant R times temperature, natural log of pressure 1 divided by pressure 2. Find the work is the same formula, and the change in U is 0. For isometric or constant volume, to find Q, it's mass times the specific heat for a fixed volume times the change in temperature. Work is 0 for a fixed volume. For change of U is the same as Q. For isobaric or constant pressure, so our volume is changing, it's MCP delta T. And then our work is pressure times V2 minus V1. And then delta U is our MCV delta T. For adiabatic, which means no heat loss, Q is 0, which makes sense because no heat loss. But then to find our work, it's a negative mass times our specific heat for a constant volume times delta T. And then for U, it's MCV change in time. And that wraps it up for tonight. I hope you enjoyed this review of Chapter 4. Thanks.